Good morning, welcome to new lecture. Today I will talk about center of gravity, center of mass and center of area. Let's first define the centroid and center of gravity and see what is the difference. Center of gravity is the point where the total weight of body acts y centroid is the geometric center of the object. The centroid is the average position of all the points of an object. This is the definition. So, center of gravity is the point where the total weight of the body acts, while centroid is the geometric center of the object, or the centroid is the average position of all points of an object. Let's see what is the similarity, what is the difference, and how we can find centroid or center of gravity for an object. Assume we have one flat plate, and this flat plate thickness is uniform, and the material, it is uniform material. For example, it is from brass or copper or steel, and this is XY plane, this is Z direction. Assume we have one flat plate here in this plane, XY plane, and the thickness is uniform, and the material property is the same in all points of this plate. If we assume one small element or small segment here in this plate, and the weight for this small element or segment, I assume it is Wi, and the distance from x-axis, it is y tilde. The distance from x-axis in the y direction for this small segment or element, if it is y tilde, what is the moment of this small segment respect to the x-axis? It will be the weight for that small segment. If, for example, I show instead of wi, wi with w1, it will be w1 times y tilde 1. So the weight times distance respect to x-axis, it will be moment respect to x-axis. If I assume another small element, this element or this small segment weight, it is w2, and the distance from x-axis, again it is y tilde 2. In that case, the moment for this segment respect to x-axis, it will be W2 times y tilde 2. So the moment of this segment respect to x, it will be W1 times distance, for second one W2 times distance, and so on. And for segment number n, it will be Wn y tilde n. If I divide this plate to n small segments or elements, pay attention, the y tilde, it is the distance of this element up to x-axis, and y tilde 2, it is the distance of this element respect to x-axis, and the distance from centroid up to x, or the distance of element up to x, it is the same, because we assume that element is very small and they are rectangular shape. So the entire this moment will be equal to the total weight. If the total weight for this plate, it is W times the distance from centroid of the plate up to x-axis, y bar. So from here I can write y bar is equal to summation of Wi x tilde I from equal to 1 to n divided by total weight. So I can write summation of I is equal to 1 to n Wi y tilde I entire weight. If I divide this plate to n, for example, segments or n element, I can write as a summation of each segment weight and the number of segment I from equal to 1 to n. This is the definition of integration of W. This is the definition of the integration of y tilde dw divided by integration of dw. So I can write as a summation, or summation is the same as integration, the definition of integration. So instead of summation, I can represent with integration of y tilde dw divided by integration of dw. So in order to find centroid in the y direction, y bar, the location of the centroid of this plate in the y direction, if I show with y bar, it will be integration of y tilde dw divided by integration of dw. The location of center of gravity in the x direction, if I show with x bar, from this we can understand that will be similar term. It will be x bar is equal to integration of x tilde dw divided by dw. If we have another third dimension, we can write the centroid or center of gravity location in the z direction is equal to integration of z tilde dw over integration of dw. So this is the definition of center of gravity, because you see we had a w. Let's take one of them and see how we can simplify that. For example, I prove y bar is equal to integration of y tilde dw divided by integration of dw. W is the weight for a small element, w1 or dw. Weight is equal to mass times gravity. So I can write this is integration of y bar, gravity times dm divided by integration of gravity dm. Because gravity acceleration is constant, I can pull out of integration. This will be gravity times y tilde dm divided by integration of dm times gravity. These two, they will cancel each other. So you see the center of gravity, if I represent with weight, if the gravity field is uniform, gravity acceleration is uniform, is the same point as center of mass. What is the mass? Mass or density is equal to mass divided by volume. From here I can write mass is equal to density times volume. So I can write this: if the mass distribution is uniform, or it is the object of property throughout the body is the same, in that case, for example, in diaphragm is still the same, still I can write y tilde rho dv divided by integration of rho dv. V here is volume, because if this is mass is equal density times volume, dm is small element mass is equal to density times dv is small volume. So I plug here. Again rho, they will cancel. So I will have integration of y tilde dv divided by integration of dv. What is the volume? Volume is equal to thickness times area. If the thickness for this plate, for this object is uniform, I can write this is equal to y tilde thickness times dA divided by thickness times dA, because thickness is uniform T, they will cancel out. This will be equal to integration of y tilde dA divided by integration of dA. So from here we can see center of gravity. If the gravity field is uniform, it is the same point as center of mass. If the mass distribution is uniform, it is the same point as center of volume. If the thickness is uniform, it is the same throughout the object, it is same as center of area. So for center of area, center of mass, center of gravity, center of volume, we will use the same method, the same formula. It starts from here. If the gravity field is uniform, I can simplify to center of the mass. If the density is uniform, I can simplify to center of volume. If the thickness is uniform, I can simplify to center of area. From here, I can write finally center of area, for example, x bar is equal to integration of x tilde dA divided by integration of dA. Center of area y bar is equal to integration of y tilde dA divided by integration of dA. So I can, from here, I can write this as a summary. I can write center of mass coincides with center of gravity as long as gravity field is treated as uniform field. Center of gravity or center of mass may lie outside the body. Later on you will see different examples. Center of mass or center of gravity or center of area or lie on a line or a plane of symmetry in a homogeneous body. So center of mass or center of area coincides with center of gravity. As long as gravity field is treated as a uniform field, center of gravity or center of mass may lie outside the body. Center of mass or center of gravity or center of area lie on a line or a plane of symmetry in a homogeneous body. Let's look at two examples. Assume we have one object or body. Shape is like this, L shape. This is 1 inch. The height is 6 inch. From here to here it is 4 inch. This thickness again it is 1 inch. I want to find the center of area for this object. And the thickness perpendicular to the board, it is uniform thickness. So I will assume one coordinate, x, y coordinate, and I assume this is origin of the coordinate. If you remember, x bar was equal to integration of x tilde dA divided by integration of dA. dA is area, total area for one object. X tilde times dA means if we divide one object to different segments or areas, each area times the distance of that area up to one axis. This term, it is meaning of the element, small element area times the distance of that element up to one axis. This term we call it moment of area. We call it moment of area. So here this term it is moment of area, and this term is total area. So total area times x bar should be equal to moment of area. Now how we will calculate the moment of area? Moment of area means area times the distance of centroid of that area up to one axis. For example, I divide this shape to two rectangular. These are two rectangular. Rectangular 1, rectangular 2. Let's find x bar. X bar means the distance of centroid for this object up to origin in the x direction. How I will find? For rectangular 1, what is the area? For rectangular one, area is equal to 1 times 6. For this rectangular area is 1 times 6 times the distance of centroid for this rectangular up to y-axis. The distance of centroid, if it is here in rectangular, it is midpoint, up to y-axis it will be 1 over 2, it will be half. This is moment of area for rectangular number 1 plus moment of area for rectangular number 2 for this rectangular. It will be area of that rectangular 1 times 4 times the distance of centroid of this rectangular up to y. The distance for this rectangular from here it will be 2 inch. Up to y-axis will be 2 plus 1, it will be 3 inch. This will be moment of area for this shape respect to y-axis. That should be equal to total area, which is 1 times 6 plus 1 times 4 times x bar. From here, I can find x bar. From here, I can find x bar. So, this is moment of area is equal to total area times x bar. From here, I can find x bar, means the centroid of this object in the x direction, the location. How about y bar? For y bar, I can take moment of area respect to x-axis. Again, I will divide to two rectangular. For rectangular number 1, it will be 1 times 6 total area times the distance of centroid up to x, it will be 3 plus for rectangular number 2 area will be 1 times 4 times the distance of centroid up to x, it will be 1 over 2, it will be half. This should be equal to total area, which is 1 times 6 plus 1 times 4 times y bar. So from here I can find y bar. Y bar means the centroid distance for this object up to x-axis. So x bar, y bar, intersection point will show us the centroid location. So let's look at another example. For example, this shape. This is coordinate x, y direction. The shape is like this, one triangle part. This is another part. Dimension 6 inch, 9 inch, 6 inch, 3 inch, and 6 inch and 6 inch. So I want to find centroid or center of area for this shape. How I will find it? First step, I will divide to different shape which I know the centroid. For example, triangle number 1. I show with this. This is triangle number 1, the red one. Square shape of number 2, this is a square shape, number 2, so triangle number 1 is square shape. I show with brown shadow, number 2, and this triangle number 3. So, I want to find first step, for example, x bar, and then I will find y bar. X bar. Moment of area for each one respect to y-axis. It will be area for triangle 1, which is 9 times 6 times half. This will be area for this triangle. Times the centroid up to y-axis. It will be 1/3 of 6, because the centroid of triangle is 2/3 from tip and 1/3 from this side. So it will times 1/3 times 6. This will be moment of area for this triangle, plus moment of area for this square shape. It will be area for that square, 6 times 6, times the distance of centroid up to y. It will be -3 times -3, plus moment of area for this triangle. It will be area for that triangle, which is 6 times 3 times half, times the centroid of this triangle up to y-axis. It will be 1/3 times 6. Summation of this, of course I make mistake, sorry. It will be 1/3 of -6. Look at here, the distance is here, 1/3 of 6, but it is in the negative x. So it will be, let's double check everything, 9 times 6 times half times 1/3 of 6 plus 6 times 6 times -3 plus 6 times 3 times half times 1/3 of -6. This will be total moment of area is equal to total area. Total area will be equal to area for each part. 6 times 9 times half plus 6 times 6 plus 3 times 6 times half. So total moment of area is equal to the total area times x bar. From here, if you calculate, you will find x bar is equal to -1 inch. So the centroid in the x direction, it will be in the negative side. Let's look at to the y bar. For y bar, I will take moment of area respect to x-axis. For triangle number 1, it will be area 9 times 6 times half times the distance of centroid up to x. It will be 2/3 times 9 plus, for this square shape, it will be 6 times 6 times the distance of centroid of this square up to x. It will be 3 plus area for this triangle. It will be 3 times 6 times half times the centroid distance up to x. It will be, pay attention, it will be 1/3 of 3 plus 6. The centroid location respect to here, it will be 1/3 of 3. 1/3 of 3, so this will be 1 inch. Plus 6, it will be 7 So instead of this, I can multiply to the 7 is equal to total area means 6 times 9 times half plus 6 times 6 plus 3 times 6 times half times y bar. From here I can find y bar is equal to 4.62 inch. Let's look at two different examples. I want to find centroid for a quarter of one circle, for example. I have coordinate x, y, and I want to find centroid for quarter of one circle like this. Of course, I make it a little bit better. Okay. The radius for this one, the total radius, it is r. I want to find centroid for this quarter of circle. Here I will follow the formula x bar is equal to x tilde dA over integration of dA, and y bar is equal to integration of y tilde dA divided by integration of dA. So I should assume a small element. You can assume any kind of element, but depend on integration skill you have and which kind of integration will be easier. So you are free to choose. I assume this kind of element. I assume element, small element in the angle direction. This angle is theta, this angle is d theta. So a small element means a small angle d theta. So the radius from here to here, it will be total r, and the length for this arc, will be, because it is a small element, it will be radius r times d theta. So the area for this small element shape, you see it is triangle shape. The area for this small element will give us dA. dA will be area for this triangle. It will be r times r d theta times half. R times r d theta, because arc in small length it is like a straight line. So r times r d theta times half. Because this is very small variation of theta, is arc like a straight line. So dA will be r times r d theta times half. Where is the centroid for this element? The centroid for triangle, for this shape, it will be 2 over 3 r. In this direction will be 2 over 3 r. So the centroid for that element, if I show on the element, the centroid for this element, G, the centroid will be 2 over 3 r from origin O up to here, okay, in this direction. It will be 2 over 3 r in the inclined direction. If I decompose that in the x direction, it will be 2 over 3 r, 2 over 3 r cosine theta. And in the y direction, it will be 2 over 3 r sine theta. I explain one more time. That element is triangle shape. The centroid here, it is 2/3 from tip, 2 over 3, because this is r. The centroid location will be 2 over 3 r. This angle is theta. So in this direction, if I decompose this, will be 2 over 3 r cosine theta. In this direction, it will be 2 over 3 r sine theta. The centroid for element. In the x direction, I show with x tilde. The centroid in the y direction, I show with y tilde. So, now, if I plug in formulation x tilde dA divided by integration of dA, this will be equal to integration of r squared over 2 d theta, because r times r will be r squared, d theta times half will be r squared over 2 d theta. Here this will be 2 over 3 r cosine theta. Let's rewrite it. It will be 2 over 3 r cosine theta. This is x tilde times dA, r squared over 2 d theta. From here, this will be equal to integration of r squared over 2 d theta. Here, again, this will be r cube, r times r squared, r cube. 2 and 2, they will cancel, over 3 integration cosine theta d theta. What is the variation for d theta? D theta can vary from 0 to pi over 2. So it will be from 0 to pi over 2, from 0 to pi over 2. From here, I can write this is equal to r cube over 3. Integration for cosine theta will be sine theta from 0 to pi over 2. This will be r squared over 2. Integration for d theta will be theta from 0 to pi over 2. If you plug this, you will end up with 4r divided by 3 pi. So the centroid location in the x direction will be 4 times the radius divided by 3 pi. For y bar, again, you will make, this is y bar. Instead of x tilde, you will plug y tilde. So this will be, instead of 2 over 3 r cosine theta, will be sine theta. If you integrate that, you will see after integration, the final answer, again, it will be 4r over 3 pi. Of course, without of that, you can understand it from common sense, because this is symmetrical shape. If it is in the x direction, if the centroid is 4r over 3 pi, in the y direction should be the same, 4r over 3 pi. So this will be the centroid location. Okay, I assign you some problems, you will work on those, and next session I will review, I will solve, and you will compare your solution. This is your homework problem. Assume we have this shape. This is H. This is A. Equation for this curve, y is equal to h over a squared times x squared. Y is equal to h over a squared, x squared. Y is equal to h over a squared times h squared. This is 8, this is h. You should find for this x bar the centroid in the x direction. This is x, this is y. This is one problem. Another problem, you have this shape, you have this curve. For this shadow part, you will find centroid. This is 4 feet. This is 4 feet. Equation for this, y is equal to x squared over 4, and y direction, x direction, find x bar, find y bar. Next one, for this circular sector, like this. For this sector, the angle is alpha and alpha, the radius is r. This is y direction, x direction. Find centroid in the x direction, find x bar. So it is circular sector. Find the centroid for this in the x direction, x bar, the radius is r, and this angle alpha and alpha. Another one, you have x and y direction for this shape. Find centroid, x bar and y bar. 6 inch, 6 inch, 6 inch, 6 inch. So entire this is 12 inch, and the shape is like this. Find centroid. The next example, it is one T section. T section. The thickness for web is 120 millimeter. The flange in each side 240 millimeter. 240 millimeter. The height for flange it is 240 millimeter, and the thickness of here, the height for web, 240 millimeter, and the thickness for flange it is 120 millimeter. So we have T section. You see the thickness for flange it is 120 millimeter. This will be 240 plus 240 plus 120. So the entire length for flange will be 240 plus 120 plus 240 millimeter. The thickness for web it is 120 millimeter. The height it is 240 millimeter. For this T section, find y bar. if your coordinate is like this. This is your x direction, this is your y direction. Try to solve these problems for next session. I will review, I will solve, and you will compare your solutions. Thank you so much for watching this lecture. See you next session. Bye bye.